So continuing with our building this network, we have the basic L2 and L3 routing with OSPF and connectivity to the firewall up and running. Let's make this a little more prettier. So if I have to put this guy in a block, I would do this. And I would call this guy campus network. And I would call this guy data center network. So now that it looks more prettier, you can see that between the campus network, you have the layer 2 all the way here, and you have layer 3 talking to each other. And then you got a layer 2 switch where you can hang more firewalls if you want. But for right now, we will shrink this into more concise fashion so that we can put these guys or add more devices. And let's continue to shrink this guy if it lets me. I have to redraw this guy. OSPF. Okay, let's see if we can redraw our campus. And redraw our data center. What we're going to do now is add a server. And connect that server to the firewall. We can do that with a switch. That this switch is the data center access switch where all the servers are going to hang on. And then we can trunk this port connecting to the firewall for all the VLANs that these servers are sitting on. So let's say we connect our first server with fast01, and then we connect our data center access switch with a gig, 2 gig 1 2. Let's move this guy here. And this VLAN 100 is a transit. Transit is anything that has no users or servers. The packet just traverses. It does not gets initiated, originated, or it does not end anywhere. So that's a transit network. So all of these links are transits. So our firewall is hanging off this. We will configure this server like here, and we'll call this transit link as VLAN 101. So now we have to configure the firewall on the VLAN 101, since this server is going to be on VLAN 101. Let's label that. And as we add more servers, we can, and if they have to be on a different VLAN, they'll come in here, and this link is now obviously going to become a trunk link. And how do we configure a trunk link on a firewall is what we're going to see here, and their default gateway is going to be the physical or logical interface on the firewall, and that's how it's going to route. It's going to advertise VLAN 101 and all the other VLANs that's going to hang off it to the OSPF router or L3 switch in the data center. There's either we enable OSPF on it, or we have static routes in this L3 switch pointing towards these. So we'll see what we can do. Let's get the IP connectivity up between the firewall and the server. For that, we would first need to configure the VLAN 101 on the switch. Let's go to VLAN 101. Configure T host name is going to be data center access, and we are configuring interface VLAN interface F fast 01, switch port access VLAN is 101. That's it, it's now converging. And while it's doing that, we will go configure this port on this port is gig 01, and it's going to be on 101 as well. Interface gig 01. Switch port access VLAN 100 or 101, sorry. Show VLAN brief, and we can see that we've put VLAN 101 on fast 01 and gig 01. The moment we bring this guy up, now let's see how we configure VLAN 101 on the firewall, because this is now going to be a trunk interface, and we are configuring interface 1.2. So we go config T interface gig 1.2 dot 101. That's how we are going to make our interface gig 1.2 a trunk by doing a 101. Interface gig 1/2 dot 101, and it does not support it. So this emulation of Cisco Packet Trace does not support sub-interfaces, which is fine. What we're going to do to work around this is we cannot configure this guy to be a trunk Therefore, we will configure this to be a VLAN 101 access. And for each other VLAN, in the real world, it's going to be a trunk port, or you can have a secondary port depending on the bandwidth that you require. If it's a 10 gig interface, you'll most likely do, and your servers are 1 gig, then you're going to do sub interfaces. If your servers are 10 gig, then you're going to have separate ports for the firewalls. It all depends. So for right now, since we cannot configure the sub interface on this emulation tool, we would configure the gig interface to be on VLAN 101, which we already configured here. So let's configure this guy. To be IP address 10.1.1.254 is the default gateway that we are using for computers and servers. And then we're going to say its name if is servers, or just say corp. Security level, we're going to say 100 and do no shut, and it's going to come up. So we had this guy configured as 101. We haven't configured it, so let's go configure it. 10.1.1.1 254 is the subnet, is the default gateway. The static address is going to be 1. We can't ping the firewall, but we should be able to ping the firewall from the firewall to the server. Okay, so now firewall can ping this server, and the firewall has two interfaces configured, gig 11, which is a transit, and gig 12, which is facing towards the server. And if we do show run, we see that we've configured corp on both the interfaces. So we're going to change this because 101 is not corp, it's data center. Interface gig 12. Name if. You need to do name if for NATs and policies, because that's what they take. They don't take IP addresses. So name if is data center. Security level is already good. Higher the better. Lower the less security. Should run. Now it's fixed. So we have the corp facing interface towards the corporate campus, and then we have the data center facing interface towards the data center servers. So now we will try to ping. We got two networks, 100 and 101, that we need to be able to advertise to our L3 switch. Let's see if this guy supports OSPF. Apparently it does. So let's do OSPF this interface, and we can put this guy in a separate area so that if we need to summarize, remember if you split the areas, it'll help you summarize from an OSPF perspective. Let's just say area 10 or 100. And so obviously this guy, if this guy is in area 100, this guy is in 100 and 0, and this guy is going to be 100. So what we did was incorrect. Let's go fix that. No network. So remember, 100 is already getting OSPF hellos from area 0, so we'll have to put this in area 0. But we'll put the 101 in area 101, let's just say. I think the address is 254. Yeah. So OSPF came up from OSPF, the firewall, towards the L3. The address of this link is 254, area 101. Just make it simpler. So now we're advertising our 101 into OSPF. And as we increase our servers on different VLANs, we can advertise those routes and summarize them if we need to towards the corporate campus and elsewhere. So let's look at our OSPF. Remember this ASA, it has different command set, and in the simulation, a lot of these commands are not supported. Show IP OSPF is supported in ASA, but apparently it's not supported here. Show IP route. Show route. That's the tricky part. You have to remember which command goes where. Here you go. We have the OSPF learn from the L3 switch here. L3 switch is advertising the network 1, 10.1.1, and 10.2.2. Okay. So now we should be able to ping 10.1.1. Here you go. And 10.2.2.2 as well. There is no such 10.2.2.1, there's 10.2.2.2. There you go. So we have connectivity between the firewall all the way to these guys. And we want to enable, and we're advertising 101, so these PCs should be able to reach this guy on a policy that the firewall permits. So if we want to create a policy that this firewall is going to permit, we're going to have to configure that. Let's say we want to configure a policy on the web server. First, we're going to have to configure the services. It's got all these services here. And if I go to services right here, by default HTTP is on and HTTPS is on, and here are the HTML files. So here's the hello world file, and there's an index.html, so let's just hit this on HTTPS. We'll try both are on, but we'll only permit HTTPS on the firewall. So let's go to the firewall, and you're going to create a policy, access list corp to BC extended permit TCP, because HTTPS is TCP. Now let's just first, before I do that, let's just first try to access it. The desktop, we go to the web browser, and we put in the HTTPS 10.1.1.1, and the address for the server was 1. We press go, and it's going to time out. There you go, it's timed out. So that's because the firewall is not permitting. So let's go permit that. Corp to DC extended permit TCP, and from is going to be, the source address is going to be, let's just say any for now. You can put it in 10.2.2. Let's just do 10. Because let's just say we want to permit only 10.2.2 VLAN 20, not these guys. So let's just do that. And to make it simple, let's just do this. Host. And destination address is going to be 101, 10.101.101.1. equal to wildcard bits. Okay, so we have to just do a host. Let's just say host. Equals to 443 is HTTPS. So here's our access list. Now we need to apply this access list to the interface. And the interface that we're going to apply is going to be inbound on this firewall. So this interface is gig gig 11. Port facing gig 11. Access group corp to BC, traffic coming in, interface corp. We applied it. Let's see if that works. Let's see if that works. Bingo, it worked. So if you were to remove the HTTPS and just do HTTP, it would not work because we just permitted 443 and HTTP is port 80. So give it a second and I'll say request timeout. There you go. And if you change this to HTTPS, it's giving you the web server page. And so this is your access list, how you did it. Basic access list, permitting a host to 10.2.2 to 101, right? And then applying it on this. We'll permit these one of these here as well, just for example sakes. Let's just see if we can customize this guy. Index, edit. Let's just say hello world is going to be welcome to Packet Tracer. Let's just say welcome to Packet Tracer is changed to welcome to my training. Save. Yes. And let's go to this guy again, just to make sure that you can actually hit these. It's a great emulation tool. 10.101.1.1. Welcome to my training. There you go. So you can customize these HTML files or upload yours as well. Let's go to this guy. 10.1.1.1. Desktop browser. HTTPS 10.101.1.1. And it's going to time out. There you go, it timed out. Let's put a policy for this host, 10.1.1.1. Bring back our access list, go back to it, just change the host to, it's not going to change, it's going to add. Control E, and this should do the trick. Browser, HTTPS. There you go. So that's how we added a firewall with access list. In the next video, I will configure a NAT for our WAN network, and we'll see how the NAT is going to work for the DMZ servers. This is just Corp campus coming into data center, accessing, and you're configuring the policies on the firewall. Hope this helps.